So in this example, we're now going to take a look at how to do the recursive image crawling program using completable futures instead of using RxJava, because we looked at RxJava in the previous lesson. Many of the things are very much the same. If you take a look at the main program, it looks almost identical to the RxJava version. We take the arguments that are passed in, parse them, and then create a new image counter object. So let's go take a look at image counter. This again has pretty much exactly the same behavior as the RxJava version does. It just uses completable future features. And it's kind of fun to compare and contrast completable futures versus RxJava to see which one is easier to write, which one is easier to understand, and so on and so forth. So again, the purpose of this code is to essentially traverse through a recursive hierarchy of directory structures or folders and count the number of images that are there, which is very similar to your assignment number 4, at least a part of it. So once again, we keep ourselves a concurrent hash map field called mUniqueIDs or URIs, and that's used to essentially avoid counting, double counting, or triple counting, or numerously counting the same page if it occurs multiple times in a recursive traversal. We also have another field here called M0. If you recall what we had for RxJava, we used a single just of 0. In this case, we use a completed future of 0 from the completable futures framework. Basically the same idea. Here's the constructor for image counter. You can see what we do is we start off by getting the root URI where we're going to traverse, and then we call the count images method. We'll take a look at that in a second. That's kind of the workhorse of this thing. And that will start with the root URI and an initial depth of 1. If anything happens to, well, no matter what happens, whether we get an exception or not, the handle method here is going to be called, and that's going to then decide what we do, whether an exception occurred. If the total images parameter to handle is null, that means an exception occurred. So we just set total images to 0, and then we print out the total number of images. So if an exception was thrown, we just kind of zero it out. But if an exception was not thrown, then we'll print the total number of images reachable from that URI. You also could have done the same thing using exceptionally and then except if you wanted to. Here's the call to join. This is the one and only call to join, and that just blocks this particular entry point method into the image counter app in order to wait for all the computations to finish. We have to do that, otherwise the program will fall off of main and it'll stop before it does anything useful. If you take a look at the RxJava version, there was a call to blocking get that had the same behavior. Here's the count images method. As you can see, this takes the URI that we're going to be searching and the depth. And we first do a little sanity check to see if we've exceeded the max depth. If so, we return the M0 completed future. We then check to see if we've already seen this particular URI before. If we have, we return M0. Otherwise, we keep going. And when we keep going, we call count images async. And that's where the concurrent processing will take place. And we'll see that in a second. We use the when complete exception method here. And we basically use this to just print out the results. So if an exception is thrown, then total images will be null and we'll print the exception message. If an exception was not thrown, then total images will be a count of the number of images, and we'll go ahead and print that out. So that's how we use when complete. That's basically the same thing we used in the RxJava version for do on success. So they have kind of similar semantics. Here is count images async, which takes the page URI and the depth. And you can see here that we start by getting a completable future to the page URI. And in this particular case, or to the page pointed to by the page URI, we're going to return a completable future to a document. The RxJava version returned a single. They're very similar. We use the var syntax here just to avoid having to be explicit. We let the compiler deduce the type. So let's go ahead and take a look at start page. Here is start page. You can see it's a little cleaner, a little neater than RxJava because essentially computable futures are all about asynchronous processing. And so you really can't start a completable future in any sensible way without doing things concurrently. So we use the supply async factory method to go ahead and initiate the download of that page. And that returns a completable future to a document. When the document has been downloaded, that completable future, of course, will trigger, just like with the RxJava version where the single would trigger after the document was downloaded. We then go ahead and fork the computation. One path will go and essentially count the number of images on the page, and the other will go ahead and recursively traverse all the images reachable from this page and count the number of images reachable from those links. So the way we do this here is we use the then apply async method, which will run this method reference in the common fork join pool. And notice this is also a little cleaner than the RxJava version, because the RxJava version you have to do a compose or a subscribe on in order to get the concurrent behavior that we're trying to get here. Those capabilities are baked in to completable futures. So it's just syntactically more concise, because that's its purpose in life, is to run things asynchronously. Here is the get images on page implementation. This is identical to the RxJava version. We go ahead and we select all the image tags on the page, and we get back an elements data structure. And then we take that elements data structure and we apply the size method that's inherited from list. And that goes ahead and just returns a count of the number of images on that page. So this looks a lot like the RxJava version, just a little bit more syntactically concise, because we don't have to subscribe on anything. Here is the other half of this fork, where we're going to go ahead and crawl any hyperlinks on this page after the page has been downloaded, of course, and that'll return essentially a count of the number of images reachable from links on that page. And we're going to use compose async, or then compose async. So this will also go ahead and run in the background. Let's go ahead and take a look at crawl links in page. Crawl links in page starts out by selecting all the hyperlinks that are on that page, if any. It could be none, but if there are any, it'll come back here. And this will come back as an elements data structure or collection. And then we convert that elements collection into a stream of element objects by using the .stream factor method. So that's a bit like the from iterable method that RxJava provides. And then for every hyperlink, we're going to call map. And what we're going to do is we're going to call count images recursively. Remember, count images is the method we have here that will recursively traverse everything. And so for each new hyperlink, if there are any on that particular page, we're going to go ahead and essentially do the same thing we did before for count images, except we're going to do it on each hyperlink that's nested inside of this page. And we increment the depth by 1. And this returns to us a stream of completable futures to integers. And then we go ahead and we collect all those things together using our stream of futures collector custom collector. So we use the toFuture factory method. That gets us back a single completable future to a stream of integers. So after all this processing, all this recursive async processing is done, the one and only completable future that was returned will trigger. We then have the then apply method called, and that goes ahead and reduces all the integers in the resulting stream and sums them up to return a single count from that corresponds to the number of images reachable from all the hyperlinks on that page. And you'll notice we pass a 0 in here, which says if there were no hyperlinks on the page, just return a 0. And of course, then apply wraps that up in a completable future. So we get a completable future to integer coming back here. So popping back up a bit, you can see that this computation runs in the background. And then the last method here is combine image counts, which you probably already guessed what it's going to do. It's going to take the images in page future and the images in links future. And when both of those things complete, we're going to call then combine. So clearly, then combine has essentially the same semantics that the zip method does in RxJava. It's similar. It's not identical, but it's basically the same idea. Zip can be used with varargs parameters. So it's a bit more like all of, if you will, but we're using it for only 2 completable futures. So the way we used it here and the way we used it in the RxJava version is essentially the same. After both these futures complete, we sum up the results. So let's go ahead and run the program. And you should see essentially the same results. And that's exactly what you see. If you were to go back and take a look, you'd see that they work very similarly. The main difference is that we see all the printouts occurring in thread 23, even though the other computations are going to be running in the background. We don't actually have them printing out from the background threads, but the places where we print the results are all coming out of this one thread. But be assured that computations are taking place in the background in the common fork join pool. So basically the same output. The structure of the program is very similar, but this approach here uses completable future features as opposed to RxJava features. So from a comparison and a contrasting point of view, I would argue that completable futures are a more concise way of being able to express the program logic asynchronously if you're doing asynchronous programming. So it kind of builds in the concurrency into the API of completable futures more succinctly, more concisely, more parsimoniously than you get with RxJava. The difference is that RxJava is really trying to do a broader range of things than completable futures. So you can also use it for synchronous processing, whereas completable futures is really inherently asynchronous. Another thing to note is that we had to combine completable futures with Java streams. In this case, we used Java sequential streams, and you can see that we used them down here in the crawl links in page mechanism. So we had to kind of combine the two frameworks that came in Java 8 in order to get the behavior we needed. Conversely, RxJava, being an implementation of the reactive streams framework, has those things baked into one abstraction. And so you get both asynchrony and the ability to compose things together in a fluent stream-like manner in the same abstraction. Of course, it's also a big honking complicated abstraction too, but it's interesting to compare and contrast the different ways of solving the same problem. And if you were to run the code and see which one worked faster, I think they'd probably perform about the same amount of time, because under the hood, they'd both be using the common fork join pool, and they're both optimized to work efficiently.